fact that air is actually made up of lots of little tiny atoms or molecules, not to scale. Okay, these are going to represent our atoms or molecules in the air, and they're bouncing around in the air. They're just flying around every which way. Okay, and then what happens is sometimes they bounce off someone, okay, or something. They could collide against each other, but if they're bouncing off of me, okay, then they're actually bouncing off, and I feel them bouncing off of me. Now you can't feel an individual atom hit you. You know, that's not. You're not going to feel that at all. Right, but lots and lots of little atoms bouncing off you all at the same time will press into you, and you can actually, well, you don't feel it per se, but you can notice if they're not there, and that's basically when you feel like a suction or something, when the atoms are not bouncing against you. And so the whole time we talk today, remember that pressure is just little tiny atoms bouncing off something to cause a force to kind of press into that. Okay? Next. I have here a little round piece of rubberized foam, and if I take it and put it on top of a soda can, I can turn it into a suction cup. And you know what a suction cup is. Suction cup is something that allows other things, just something to stick to different surfaces. And I've got a suction cup attached to the can right here. So I can take this can and I can put it down on the tray, and I can pick up the whole tray. I can hold the tray upside down, and it stays there, and it even just hangs there on the side. And if I try and pull it off the tray, it doesn't come off the tray. It's actually pretty hard. I can slide it off, but pulling it straight off takes a lot of force. And in fact, if we look at the circle here, at the instructions, it tells us how much force is on a circle this size. At about standard pressure here, which is due to the atmosphere over our heads, the pressure is about 220 pounds. 220 pounds of air is pushing down on this circle. And where's the pressure coming from? Well, it's because we've got miles and miles of air over our heads. Okay, and that's all sitting down on our heads. Just like if you dive into a deep part of a swimming pool, you can feel that as you go to the deep end, your ears can feel the pressure of the water on your head. All right? In the same way, all the air over our heads is pushing down on us. And that comes through in another case. We can use that air and then use it to do cool little experiments. And so let's use it to do a little recycling. So here I have an aluminum can, and I put a little bit of water on the bottom, and then that water is now starting to boil, and it's filling up the can with steam. All right, and the steam, of course, is hot, and we can talk about some other time how the steam fills up the can and pushes all the air out. And I'm going to take this can and I'm going to turn it upside down in some water so that all the water inside that is now gas and force the air out will go away. And so when I turn the can upside down, all the air, basically all the pressure inside will go away, and the pressure of the atmosphere will then crush it. So here we go. Ready, and go. And here you got a little recycling due to the pressure of the atmosphere around it. Well, you can take a juice box. I can get the juice out of the juice box by squeezing the sides. If I squeeze the sides, you get a little juice out. All right, and then you got to eat it fast before it spills all over the table. Or if you want to be a little cleaner, you can pull with your mouth and get the juice out. But you're not really pulling with your mouth. The box is still getting squished. All you do is kind of reduce the air pressure in your mouth and let the atmosphere do the work. The miles and miles of air over our heads are squishing down on the juice box, and you kind of relax your mouth and get the air out of your mouth, and the air around us shoves the juice up in your mouth. Yeah, why should you do all the work?